Today we're on 6-1 Relations and Functions on page 157. The objectives here are to identify relations and functions, to represent relations with tables, mapping diagrams, graphs, and equations, then to identify the domain and range of a relation, and then to evaluate a function using function notation. So, a relation is a set of ordered pairs. So we know, we've all seen XY in Battleship when we were or on a coordinate plane in math class, okay? Right here, this represents your X, this represents your Y, X, Y, X, Y, X, and Y, okay? This right here is a relation, or a set of ordered pairs. Right here, 12, 3 is an ordered pair. So right here all together in these brackets, my favorite thing to write in math, is a relation, okay? Your X comes first, comma, then your Y, okay? Your X coordinates, or your input values, okay, are called the domain of a relation. So right here, the domain of each of these relations is going to be 2, -3, and 5. This is your domain of this particular relation, okay? So your X coordinates are known as your input values and as the domain. Okay, they go by 3 different things. All right, your Y coordinates, which would be 12, -3, and 4, are your Y coordinates, or your output values. They're called the range of the relation. So this would be right here, the range of the relation. Okay? Alrighty. A function is a special relation. Each element of the domain, or each X value, is paired with exactly one of the range or the Y value. So no two ordered pairs have the same first element and different second elements. Second elements. Okay? So for instance, if we had, let's say over here in our range, get a different color here, we had a relation that had 2, 1, 5, 7, 6, -10. Okay? Put all of our domain, or X values, over here, and all of our range values over here. So we would put 2, 5, and 6. I'm going to erase this here so we have some room. Okay? Then we would put our range, this is our range over here. Domain and range are X and Y values. Okay? And over here, let's use orange. We have 1, 5, and -10. Okay? 2 goes with the 1. 5 goes, oopsie, it's supposed to be 7. I'm sorry, my bad. 5 matches up with 7, and 6 goes with -10. So this is a function because each of the domains have different second elements, okay, or different ranges. Okay? Alright, so let's say that we had a relation that was like 7, 5, 6, -2, and then 7, 3. Let's set up our mapping diagram. Okay, so just draw 2 ovals. We draw our X values here, our Y values here. So over here we have 7, 6, and 7. Then we put our ranges over here, Y values. We have 5, -2, and 3. Okay? So let's match these bad boys up. So we have, let's get a different color. We have 7 going to 5. Okay? And then we have 6 going to -2. Then we have 7 again going to a different pair. So, in essence, we wouldn't write this 7 down because we already have a 7 in here. So we would draw it just like this. So 7 has a value of -2, has a value of 5. It goes with 5 and it goes with 3. This is not a function. Okay? 7 can only go with 5 or can only go with 3. But unfortunately, it's paired up with both of them. So if you have if you just look at the relation set up as a set of ordered pairs, and you see that you have more than one domain in a different order pair, it is not a function. It is a function. Let's say that you had 7, 5, 7, 5. That is a function. But you can't have like 3, -1, and then 3 and 2. 3 can only go with -1 or the positive 2. Okay? Alright, so let's do another one. Let's do another, see if it's a function or not. So we have 0 and 0. Then we have 1, -1. Then we have 1, +3. Then we have 2, -1. Nope. Let's do 2, -10. And that's it. Okay? So 0 matches up with 0. 0 only has one range. Okay, that's cool. Then we have, so we're going to underline all of our x values here. Alright, so we have 0, 1, 1, 2. Alright, what matches up with 0 is 1. I'm sorry, 0. What matches up with 1 is -1 and 3. So this already has 2 output values, so this is not a function. Okay? Alright, let's talk about function notation. Okay, so this is on top of page 157. Function notation looks like this. You have an f, then right next in parentheses you have an x. So this is saying f of x right here. That's what that's saying. Alrighty? So, you're going to evaluate functions, and it's going to look like this. So it'll say, let's go over here. So for f, oopsie. So sorry. I'll say something like for f of x equals 3x minus 4. Okay? Then it'll tell you that f and f of -4. That's what it's going to look like. It sounds like really weird language. So, and find f of -4. So this is saying when x equals -4, so you're going to plug in a -4 for x. So all you're going to do is plug in -4 for where your x values are. So we have f of -4 equals 3 times -4 minus 4. Okay? So when x equals -4 in the f of x formation, it's going to equal -12 minus 4. Okay, which is going to be negative f of x. F of -4 is going to equal -16. So, what we're doing here is we're trying to find the y value. F of x, which seems, I know, even crazier to say this, f of x equals y. That's another way to find your y value. Okay? So, when you put in a value for x, you're solving for your y value. So we knew right here that my x equals -4. So in this coordinate, x is -4. When x equals -4, y is going to be -16. So your new coordinate pair is going to be -4, -16. Okay? Your f of x equals y. That is what your y is. That is just function notation. It sounds like a lot of different wording and crazy and weird, but that is what it equals. So let's say that f of x equals -x squared, and it'll say find f of 6. Okay? All we do is we plug in this value for x. So f of 6 equals -6 squared, which is going to be a -36. Alrighty? So, in our coordinate pair, we knew that x equals 6 because it told us that here. We plugged that in for x to solve for y. And y is going to equal -36. Okay? Alrighty. The other way to find out if a relation is a function is by doing the vertical line test. So they'll give you a graph. Actually, let's pull this up. They'll give you a graph like this, okay? There'll be a line drawn on it, so there'll be a line like this drawn on it, okay? And you have to tell me if it's a function or not. All you're doing is you're going to draw one vertical line right here, or anywhere on the graph. If your vertical line that you're drawing on this particular graph hits the line in this red, the line in red, one time, it is a function. If it hits it in one spot. Now let's say I wanted to draw a line. I'm going to draw another line. I'm going to draw it right here. It still only hit this red line in one spot, so it's a function. Let's do another one. Let's say the line looked like this. Okay, I've given you this graph. You have this line on it. The vertical line test is you're going to draw through the graph of the relation, and it intersects the graph in at most one spot. It is a relation. So let's draw another line. Does it hit my graph in more than one spot? Nope, hit it perfectly right there. So that tells me this is a function. Okay, I'm going to draw one more vertical line right here. Oh, it only hit it in one spot. It is a function. What if I drew another line right here? Only hit it right there. So it is a function. All right, let's draw, what if I have a circle on a graph? Okay, I draw my vertical line, say I draw it right here. It hit right here and right here. So it hit more in one spot than in one spot, excuse me. So this is not a function. Let me try it again. Let me just make sure that I'm totally right here. So I'm going to draw one right here. Oh, it hit right here and it hit right here. If your vertical line that you're drawing on the graph hits in more than one spot, it is not a function. Okay? Let's do one more. What if we have a line that looks like this? Actually, I just drew one like that. Let's draw one like... Okay, you're given this line on a graph. Let's do a vertical line test. Oh, hits in one spot. Let's check it again. One more vertical line. Hits only in one spot. So this is a function. Okay? Alright, let's do one of the try these together. Let's do number one of the try these together. Okay. So it gives us the relation of 4, 0, 4, 1, 4, 2, and then it gives us 4, 3. Okay? It says write the domain and range of each relation. Is each relation a function? Okay? So let's write our domain. And we have our range. Okay. So we have a 4, a 4, a 4, a 4. So the only number for our domain is going to be a 4. Okay? Our range, we have 1, 0. We have a 1, 2, and a 3. The 4 matches up to each one of these. So this one, 4, has more than one range, so this is not a function. Not a function. And if you're wondering why I'm not writing down all those 4s, you only write down the numbers you only write down each number once. So let's do another example. Let's say we had like 6, 1, 7, 3, 6, 2, and 4, 0. Okay, we draw our mapping diagram. I have a 6, I have a 7, I already have a 6, so I don't need to write that again, and then I have a 0. Okay? Then for my range, I have 1, 3, 2, 0. This 6 goes to the 1, the 6 also goes to the 2. Alright, 7 goes to 3, 0 goes, that wasn't 2.